All right, so let's take a look at this warm-up. And I loved what I heard in the back. So basically, this column is copying this column. How come? Say it out loud, Adney. Yeah, so parallel lines have to have the same slope. So if this slope is -2, then the slope of B is also going to have to be -2. Now here's something interesting, and I want you to think about this. I'm not going to write this as 0.8. I'm going to write it as a fraction. We have to stop being nervous about the fractions. We have to stop being afraid of the fractions. So 8/10 is the same as what simplified fraction? Who knows? 8/10. 4/5. And here's why I'm going to write this as 4/5. That's workable information for what I'm doing. Because I know a rise of 4 and a run of 5 is easier for me to understand on the graph than 0.8. We read 0.8, and way back in my earlier years when I was like, I'm changing the world, I used to try to tell students that they were never allowed to read a decimal as 0.8. But sometimes it makes it easier if somebody's writing down what you're saying to say 0.08 or 0.8 or point. So, okay, I'm fine with the point. I've relaxed on that standard. But when I'm doing decimal work, because I got a little bit of a hint here, when I start doing the slope that's perpendicular, 0.8 doesn't help me. But does 4/5? Yeah. So we need to be okay with the fractions. We need to understand that fractions are just little mini division problems. They're ratios. They're easiest if we keep them in our friendly numbers. That's why we simplify. And the more you spin the fractions around in your head, the better you will be. Start now. Start now. Force yourself to a higher level of accountability when it comes to number sense. If you're weak in number sense now, it's okay. Just work harder. That's all there is to it. Olivia, I saw your hand go up and down, up and down. Do you have a question for me?
I have a question on, I figured out myself why you put MB.
Yeah.
It's like you're solving for line B.
Yeah, that's the slope of line B. Go put a Smarty up for figuring it out. Because what we're talking about is the variable m, little baby m, represents slope. But if I'm talking about two separate lines, anytime I can mathematically make it clearer to communicate what it is I'm talking about, then everybody wins. So that you know what I'm talking about. So that's why I did the slope of line B. All right. So just to do what my fabulous group in the back said, and I'm going to do the same thing here, -3/10. And then my slope of line B is going to be the opposite of x. We're not putting -1 there. That x is the slope. I don't know what it is. It's a variable. I might use a different variable than x. I've got 25 other ones to pick from. So, but that's not going to be my x as my input. So that's just going to be that slope. Okay, here's the fun part. When I want to find the slope of line B that's perpendicular, if this is negative, this is going to be positive. If this is, and pretend like you see a little 2/1, that's where I get my 1/2. Think about me and Keith Berkeley. Over there, we're reciprocals of each other. All right. Go ahead.
So if it was a positive 2, would you put -1/2?
Yes, ma'am. In fact, that's what I'm going to do here. See how this is positive? The slope of my perpendicular line is negative, and it's this reciprocal. The slope of B that's perpendicular to this is positive. So I want negative, do the reciprocal. The slope of B that's perpendicular, this is negative, so I want positive. And I wrote it in a fraction. That makes it easier for me to find the reciprocal. Don't be afraid of the fractions. The slope of line B, that's perpendicular. This is negative, so it's going to be positive, and it's going to be 1 over whatever that value is for x. Go.
So I can't put
No, because, and that's a great question, lead in, because just having one of the two conditions doesn't give us perpendicular lines. So I want you to draw on your paper a really, really steep positive line. Then I want you to draw a negative line of the same steepness. And we can suppose what we think those slopes would be. Let's say that this is a slope of positive 3, and let's say this is a slope of negative 3. In any world, are those lines perpendicular? No. In fact, you can do it with your arms. Give me this. Give it to me really flat. These slopes are both really steep, one positive, one negative. These slopes are really flat, one positive, one negative. Either of those situations perpendicular? No. So it's not enough. Go.
Wouldn't it just be 1x, because can't we assume if it's just x, then x equals 1, or?
Well, x is whatever value is coming in for x. So if I told you x has a value of 3, then this slope would be negative 3, and this slope would be positive 1/3.
I meant, like, can't you assume if there's no number before the x, then it's like 1?
No, but because that isn't my x, this is, my slope is equal to this. So this is my slope, and then this is the coefficient in front. That's why I said using x as a variable was a lousy choice. Let's say it was negative a.
Okay, yeah.
Does that make more sense? Because x is a lousy choice for the variable, right? Go ahead.
So how would we do it if it was 3x? Would we do 3 on, I can't say it, like 3 on the side of the fraction?
So 3 is a coefficient to x. That would be this story. So if I had a slope that was 3, or if x had a value of 3, I'm putting 3 in for x, and then that's what my answers would be.
But what if it was like 3x and b equals 3x?
If my equation was y is equal to 3x, in this circumstance, my slope is 3, and then the line that's perpendicular would be y is equal to negative 1/3 x. There's my opposite, there's my reciprocal.
Oh.
Do you see it? Okay. All right. So come back over here, and now on the side of your paper, I want you to sketch a line that is pretty steep again. Go back to your idea of a slope equaling 3. Then I want you to draw a line that's also positive but pretty flat. And that is going to have a slope of 1/3. Anybody want to say those lines are perpendicular?
Yes. No.
Because they're not negative. So one is, I need both of those conditions to be true. In order for my lines to be perpendicular, I need one to be steep, and I need one to be flat. I need one to be positive and the other to be negative. I need opposite reciprocals. I need both of those stories at the same time.
Does that mean the blue wing down on the top is perpendicular?
No, because those were opposites.
Oh, okay.
Here's a picture of opposites. Here's a picture of opposites. Here's a picture of reciprocals. Here's a picture of both. If you want lines are perpendicular, both things have to happen. Okay? All right. Writing each equation in slope-intercept form. So slope-intercept form is where I have y is equal to mx plus b. We are not creative when we name things in mathematics. It's called slope-intercept form because it gives us our slope and it tells us our y-intercept. This equation is super cool because it's given to us in point slope form. Here's my slope, and here's my x and my y ordered pair. This equation is in standard form because both my x and y are on the same side of the equation, and they're both integers. There's an infinite number of point slope and standard form equations. Infinite. There's one slope intercept form. So would you please simplify both of these? Solve for y. Get it so it's y is equal to on each one, and that'll be your slope intercept form. Talk to your group mates. Go. Ready? Here we go. Point slope form is pretty cool. How'd you do? Slope of 3, intercept of 15. When it's in standard form, I need to get y by itself, so I'll subtract 12x. That gives me 4y is equal to negative 12x minus 32. Somebody last class wanted to put these together. I said you can't. These are variables. These are constants. They're not like terms. Divide by 4. I have to divide everything by 4. Distribute that division. So my y is equal to negative 3x minus 8. A slope of negative 3. And an intercept of negative 8. Quick question. Are these two lines perpendicular?
Yes, because it's not too yes, because the slope. No. Because they don't have the opposite.
Yes, they're opposites. No, they're not reciprocals. Are they parallel?
No.
Because they're opposites. Okay, determine if the following lines are parallel, perpendicular, or neither. In order for me to determine slope, I have to put it in slope-intercept form. And in order for me to do that, I need to solve for y. So our whole goal in reviewing all of this algebra with you is having you be able to look at this equation and solve for y. Add x to both sides, divide everything by 2. This equation has a slope of 1/2. Solve this equation for y. Subtract 2x from each other. I'm done. This line has a slope of negative 2. Are those lines parallel, perpendicular, or neither? Definitely perpendicular. The slopes are opposite reciprocals. Hey, we gave you a gift on this one. Here's a slope of 4. Here's a slope of negative 2. Parallel, perpendicular, or neither? They are neither. All right, here we go. Write the equation of the line parallel to the given in point slope form. Here's our given. If we want the line to be parallel, what do I know about its slope? Okay, that means that parallel lines are going to have the same slope. So when I go get my point slope form, I know that y minus y1 is equal to m times x minus x1. When I write it in point slope form, here's my y. Y minus 4 is equal to, here's my slope, 1/2 times x. When I do minus negative 3, y minus 4 is equal to 1/2 times x plus 3. If they want it in point slope form, I'm done. There's no need to simplify because they didn't ask me to. We like point slope form because in point slope form, I can see a point and I can see a slope. I told you, we're not creative. Let's call that point slope form. How come? Because we can see a point and we can see the slope. We like that. All right, next up, write the equation of the line perpendicular to the given in slope-intercept form. Again, I have a slope of 1/2. What is the slope of my perpendicular line? Negative 2 over 1 or just negative 2? Now I gotta be honest with you, if you want to substitute into y equals mx plus b, you can. It'll still work. I totally prefer to use point slope form. I find that easiest. If you are a person who solved for B, make sure you remember to plug it back in. What questions do you have about this process? Go, Rachel.
Isn't the slope 1/2 of it?
But the slope was 1/2, but I'm writing the equation of a line perpendicular.
I didn't see.
Yep. That's okay. Go ahead, Olivia.
I need help trying to figure out whether, when we're looking at the equation, if it's perpendicular parallel.
So you have to look at the slope. The slope is a coefficient on the x. So if you read that, it told you that I want it perpendicular, so that's why I made this slope. If you come up to a sample like this, where they're asking you parallel or perpendicular, it's all about looking at the slopes. So that coefficient on the x, once you solve for y, once you get y isolated, y is equal to whatever that coefficient is on the x, that's your slope. If they're the same, they're parallel. If they're different, not parallel.
So I don't have to look at the,
All you have to do is solve for x or solve for y.
okay.
Go, Rachel.
Wasn't it, should it be plus 4?
So this slope-intercept form is set up in a naturally negative situation.
Mm-hmm.
So this positive 4 becomes y minus positive 4. That's why this negative 3 ends up positive, because it's minus a negative. And that's what I showed you up here. X minus negative 3 turns into x plus 3. Because that double negative cancels each other out.
But you don't add 4 once you get to the final thing?
I did add 4. When I added 4, I added 4. Negative 6 plus 4 more is negative 2. That's okay. Keep asking. Go ahead.
Why do they have it as a negative, like, y minus y1?
I love it. Hey, I want to see I want to show you something cool. Ready? This is just as an extra. Flip over on your back if you care. If not, just watch. Slope is change in y over change in x, right? Say yes.
Yes.
y2 minus y1, x2 minus x1. You okay with that?
Yeah.
So if I'm going to say that is equal to m, I'm just going to pretend like this doesn't exist. Are you okay with that? Okay. If I wanted to bubble wrap this expression and keep it the same, if I want to get this out of the denominator, I am allowed to multiply both sides of my equation by the same thing. The multiplication property of equality tells me I'm allowed to do that. Is everybody okay with that? Multiplying this side of the equation by what's in this bubble, this side of the equation what's in this bubble. Everybody with me there? Yeah? If I have x over 3 is equal to 6, are you okay with me multiplying each side by 3 to get x is equal to 18? Same thing. Now are you okay? Okay. Just like this 3 and this 3 cancel out, this and this cancel out. You don't need to memorize this, just understand it. Ready? You ready for what comes next? y2 minus y1 is equal to m times x2 minus x1. Does it look familiar yet? Does it look familiar yet? I don't need 2 points, but in every equation I do need an x and a y. Here's point slope form. Point slope form comes from slope form. This change in y over change in x that you've been using for a year, all I need to do is apply some mad algebra skills and I can manipulate it into point slope form. That's where it comes from. So if you ever forget it, go back to what you know. I know that this is true, but I'm going to multiply each side by my x's and put them over here with my m. So then this is my ordered pair that I plug in. This is my slope. And when I simplify that, I get y equals mx plus b. When you simplify this, you get that. Hey,